All right, so yesterday we started with terrain models, how to import the existing terrain. Imported the tin. We looked at how we can modify it and all that. We then created the horizontal alignment using the horizontal alignment tools or horizontal geometry tools. We then created a profile for that alignment and activated it. And then that was everything we needed to run a corridor. We then chose one of the corridors that were in the text.template library. We ran a 2-lane road and we modified some of the geometry by adding like a right turn lane, some widening, and then we also created a ditch flow line and profile. And we tied it using a point control to the template. And we looked at parametric constraints as well in areas where we're outside the right of way, how we can push it in through like a station range. And lastly, we took a look at how to determine how to like work with display rules. We're gonna go over that quickly. I'm gonna do it this time on the left side. So so I'm gonna open the template library that we are working in.
What are we gonna do on the left side?
The retaining wall. So we're just gonna do that quick again. It doesn't, I'm not sure where my retaining wall is. Oh, I think it's this template, yeah. Let's see, test all. Yeah, it's this one. So, just an FYI, once you apply something on one side, you can always apply it on the other by just dragging and dropping. So, for example, I want to get this mirrored to the other side. I don't have to redo everything that I've done. I can just click in here. I'll have to make this turn on first. So let me make this slope minus 50, for example. Okay. And then I can drag it. You see this picture on the left? I can drag it. Now I have another copy. While I'm still holding it, I right click and do reflect. Now I'm still holding it, and then I just drop it like that. Of course, I don't need all those, so I'm gonna delete components, delete everything here, and just keep my retaining wall. And just right click, move point, and snap it to the edge of pavement point. Okay. That way I save myself a lot of time and effort. So that's one way to do it. Of course, you have to modify some things. So for example, right now I have 2 points on top of each other. So I have to right click and there's a button called merge points. So I click on merge points and I delete the one that I don't want. I want to keep the edge of pavement left. I don't want to play with that one. So I merge them and I delete the extra one. Now I have my retaining wall. Of course, I have to modify the display rule because now this will be tied to these 2 points, not these 2 points that were here. So I have to create a new one and change it from here. But I'm gonna restart doing it from scratch. That way it's recorded as well. So yes, let me just do. So we're gonna delete component. I'm gonna delete this one. There's no point for that one at this point. So right now this, if I double click on it, double click on the point, it shows me that it's looking for the existing ground. I don't want it to do that. It was causing some issues if y'all remember. So since this is an end condition, I want to delete this point, but I want to keep the end point. So let's say I've already tied that point to the right of way. I don't want to get rid of that. So I can right click on a point and click on delete from components. Okay, make null. That keeps the point, but it deletes anything tied to it. So say I want to do it to this point. It's the same idea. Delete from components. It just keeps the point, but deletes everything tied to it. You're gonna right click and add a new component, and this is going to be a constrained component. I'm going to choose the feature definition, and then I'm just going to connect these 2 points. Right click and hit finish. As you see, I've recreated this, except now if I double click here, there's no checkboxes for seeking existing, or it doesn't have some of the properties that are in the end condition anymore. So it's just a simple line. That's it. That's all it's doing. Slope is 10 to 1. That's fine. All right. So I'm gonna add a new component again. This time is going to be constrained as well. I'm going to call this concrete, or yeah, sure. Let's just do riprap. It's going to look like this. I'm just trying to mirror what's on the left side. Then simple component, we said, right? This is going to be 0 slope, thickness 3 feet, width will be 1 foot. I'm just going to put it right where this point is. Now, when I did this, when you're adding a new component and you're putting it on a point, you don't have to merge points. It merges them on its own. So if I right click, I don't see the option to merge points. Again, add the footing, simple, make it 3 feet, thickness 1 foot. Then we just put it somewhere here. Then double click on this and tie it horizontally and vertically to this point. That way those two move together. And close. And then what we did was created this point, like the point that seeks the existing ground. So I'm going to right click, insert point, finish. This will project to surface. So project to surface, like, it makes sense, right? It just goes up and down based on where it finds the existing ground. But for this to work, it needs to have a horizontal constraint as well. So I'm going to choose horizontal and then click on this crosshair to select something like a point to be horizontally constrained to. Hit apply. You notice it removes the fill from that shape. So now we just need to test it. If we go to test, terrain model, draw, we notice it's not working how it's supposed to. Like, it's connecting the point to the existing terrain, but it's just a point. Like, nothing else is moving with it. So come back, double check this. This is connected to 3L. Where's 3L? Yeah, this. So that bottom point is constrained to the top point. It's not constrained to this. We want it to be constrained to this. On the crosshair, click on the crosshair, and let's test it again. Draw. Okay, so now that point is, but now this point is not anymore. So I need to make sure this point is constrained to this as well, not to some other point. So constrain it horizontal, constrain it vertical. Now we should be good to go. See that? Now let me just verify the slope here. 7 feet. I mean, we can just do it based off of the slope from edge of pavement left. Let's just do 16.67. All right. We are good to go. So we've created the components. Now I need to create the display rule. So let's see. Now I want this to be hidden whenever this one shows up. So go to edit display rules. I'm gonna add a new one. This one is gonna be a slope display rule between this point and this point. And we're gonna say this is above or equals 33%. Okay. Let's try that. Oh, I need to make this the inverse. So not this one. This is the one that we just created. This one needs to be apparent off the wall as well. So select this, apply and close, and this one as well. I need to make it apparent off of this wall. All right. Now, if we are to do this, okay, looks like the slope is too high. So we got some issue. So, oh, not sure why I took it up. 0%. Okay. Yeah. Fine, close. Let's try that again. Okay, see, so this is approximately the 33%. So it goes, so it's doing the opposite of what I want it to do. So edit again, edit, do less than or equals to, hit okay, apply, close. All right, see that? So now it's displaying the wall when I want it to display it. Now I just need to make this not this one. Yeah, trying to find out. Let's see. Okay, now it's good. Cool. So whenever it's more than 3 to 1, I just display the wall. Once it becomes dotted, it's kind of hard to select the best point controls.
What's that like indicate? That like why does it come?
Oh, so I'm turning on the display all components and off. That
Oh,
way,
okay.
things that get hidden, I
So
can
it's
still
like-
see where they are, like a ghost of them. This kind of shows you if there's a display rule or not. Okay. So this point, we'll call it 10 to 1 left. Right. Hit close and save. And now we're gonna add a point control for this corridor, starting right here and ending somewhere here. So this is gonna be a flow line, not flow line. This is gonna be right away left. The point that we're gonna do is the 10 to 1. Oh, yeah, there's the override. Let's see what the name of the override was. Ditch flow line left. Go here, ditch flow line left. These are gonna be both linear geometry. Select the right of way, accept the profile. Just accept and click on these. Okay. So it has now tied it to the right of way. Take a look at the cross section. Working good. If you notice, it doesn't look like we need wall on based on the parameters we gave it. Oh, forgot the resync constant or something off. Okay, there we go. Okay, we do need wall right here. Yep. And at this section exactly, we need wall on both sides, for example. Cool.
So let me remember real quick. So if we're in that view two, we can do a right click and jump. Remember how you said you didn't want to have to jump through all the cross sections one by
Yes.
one?
Mm-hmm. You
Is
can
that
right click
click?
and hold, yeah,
Uh,
and then go to locate station and view data point.
and you just, and then it will show up on the plan view where you want to go
And
to.
then it tells me where's the view.
Uh,
I click inside the view, and then it shows me this line.
So,
I can tell it, okay, cut a section right here, for example.
so I'm a little bit interested in right now. So we are in, see how many sections we got?
Mm-hmm.
They just look at like, how did it, like if we were doing, what's the method behind how many we got? That's pretty good that we got a bunch of, if each green line is a section, that's really good, but,
Yeah.
I thought that when you're in preliminary, they cut sections maybe every so often.
Mm.
When you go to design, they get tighter, and then at this stage, there's a bunch of cross sections. How do,
This is the final one.
so you're in the final, that's
So I
right.
go to design, it reduces them a little bit. And then preliminary reduces them a lot. But when you have point controls, it adds a lot more to make sure that it's tying in how you want it to tie in.
Point control will do that too.
Yeah. So
It just automatically does that.
yeah.
Did
Which
it
is
change it from did it change from preliminary to design, or it just did it remain unchanged, but just added cross sections?
so regardless of the stage,
Uh-huh.
it still added cross sections.
Okay.
Because it wants to do what it's supposed to be doing, which is tying into the right of way. And what was I gonna say? Yeah, so one thing I wanted to mention is in terms of computing power, point controls is one of the higher demanding tools. So first it's display rules, then you get the parametric constraints, and then the point controls is the highest. If you want like a smoother model, less like something fast, right? That wouldn't really be slow to work with. You'll try to avoid using too many point controls. I mean, you have to use them in some places, but you try to avoid some if you can.
Point control, parametric, and display ruler.
Yeah.
So number one, most demanding point control. Two is parametric. Three is display rule.
Yeah. Right, so I guess that would be it for display rules. I mean, of course, we can use those for a lot of different ways. So you can have like a flat bottom ditch, and then if it goes down, it becomes like a V. It starts to become a V. So I can show you some of the templates that I have previously. Let me see. So for example, this is like a ditch template, right? Could be, you can have your pavement on either side. And if I were to test this, I mean, this one is not working, right? Hold on. This is a flat bottom one. This is a little... So this is like, for example, the ditch next to the retaining wall. And what this one does, it controls the wall height based on the flow line as well. So deeper the ditch gets, the higher the wall.
So again, in that view over here on the preview, you create your own individual template and then you copy it over to your roadway template like you did for the wall.
So this is just a preview of these.
Right, but you remember how you said you're saving work?
Oh, yeah, you can just drag it.
You borrow that and
You can
I'm
borrow
gonna add it to my,
Yeah, because I can create a roadway template, right? And just click on any of these. For example, I want to have this in here, just drag it and drop it.
I got you.
So let's say you created your SSTR, right? You did it up to standard, you added all the curves and the details of a single slope concrete barrier. You don't want to do it again. So you can just create a component for that, like a template for that. And every time you want to use it, you just drag it and drop it and put it on top of your pavement.
One other thing is the
Hmm.
wall, you did reflect. There was also a mirror on there.
Yes. Yeah.
What's exactly the difference between reflect and mirror? I would have used mirror by accident.
Yeah, mirror is just, it does it on two sides. So if I right click on mirror, this is the mirror.
Oh, both sides.
Yeah.
Okay.
Reflect is just flipping it. Okay. Like for example, we also have this, we made this template where we can kind of determine like a ditch capacity quick. You see that blue line? Kind of goes up to the right of way or chooses which side like it needs to go to. So There is one that I have, but I don't think I have it here. Yeah, anyways, like I have one where it's flat bottom, and if it goes to this point, I have a display rule that changes it to a different color, shows like an orange color, for example, telling me that I'm already exceeding my 3-to-1s, because this is 3-to-1 max. So I would know that, okay, in these areas, my flow line wouldn't work. I need to raise the flow line a little bit to make it work. So different things you can do with display rules. I also have one where, the reinforced backfill behind the retaining wall. I also have that modeled in the template, and you know how that depends, like the width of it depends on the height of the wall, depending on the geotech report. So I have that link between the two, where I have it like if it's this multiplied by 0.8 width, if it's this height multiplied by 1, for example. So I have different rules for that. All right, I think that's enough for display rules. Let's move on to the important topic, which is why we have the training. And that is the cross culvert. So different ways to do the cross culvert. There's the manual one, which is just really cutting existing ground and trying to figure out, okay, the roadway profile is at this point, and let me just draw the pavement manually and do everything manually, right? That's like the old school way. I'm gonna show you the modeling way, how you can do it. You can model it and then start the manual manipulation after. So first thing is I want to model the culvert. So I'm going to start a new file. And I'm going to use a 2D seed as well. And we're going to call this drainage. Okay. You want to have that in a separate file because it's drainage and utilities component. And when we place drainage and utility components, it changes the file type to like a special kind of, has new properties to it related to drainage. And it's not reversible. So let's say you put your culvert in your corridor. Like every time you open your corridor, it asks you, like it pulls up all the drainage libraries and the SCTs. You don't want that. It just makes it slower. So just put it in a separate file. I'm gonna attach the existing alignment. By the way, everything really in here. Okay. Of course, every time I reattach, I reactivate the existing. I rotate this and save settings. And now let's see where the culvert would be here. So based off of the existing, where's the existing culvert?
The ones we're replacing.
Mm-hmm.
Turn on the aerial, will be useful.
Okay. Oh yeah,
There's a couple of them on the road.
it's a good thing you mentioned that because I wanted to go over that yesterday and I forgot. So how do I turn on the aerial? View control, yes. But it doesn't give it to me by default, right? So I'll have to assign a coordinate system to the project for that to work. So if you go to the coordinate systems, what is the coordinate system here?
Yeah.
We are north or central? Central. Yeah, so this is the one that I usually use, the NAD 83, Texas State Plains, Central Zone, US foot. Okay. Now you see here at the bottom right, I used to have an X, a red X, now it has a check. That means I'm good. I have a coordinate system now. If I click this, now this shows up. This wasn't here before. I go to aerial. And it loaded, but it doesn't look like it's in the right place.
Might be South Central.
Is it this one over here or no? Or is it completely separate?
But the surveyor didn't give, like.
Oh, they didn't put it in the right place?
Yeah, I have to like, every single time I referenced in the terrain, I had to like apply on the references, like moving it a certain amount.
Oh, I see. So where is the road?
It's that one you just
This one here?
zoom out.
Mhm.
Oh, closer. Sorry, I know we're rotated. Okay, yeah, it's that one.
This
Yeah.
one here.
Mhm.
Okay. Then what it looks to me like this is in grid. He gave you the sorry, the area is in grid. But I think the surveyor gave it to you in surface, which is correct, right? So we just need to change the aerial to be in surface rather than grid.
We
So
usually use these like tiles, but somebody,
aerial tiles.
yeah.
Yeah, we can do that. Let's try the first one first. So just to show you how to modify this and make it into surface. So I go to the properties of the coordinate system and I apply a transform. It's called the Helmer transform. Now I need to apply a scale factor. Remember the scale factor that we usually apply? This is it here. So what's the typical scale factor here? Is it the 1.0013 or
I
12?
feel like for this project it was 1.0018, but it was 1.2.
So
I've heard all of those before, so I think you can try either one. We'll get you closer.
yeah, let's give it a try. 1 divided by 1.0012.
Yeah.
Let's try that. So I copy this number. I place it right here. Okay. Hit OK. Tells me it's not supported by other versions. I don't care about this. Just say OK. Okay, we're closer. I think it's the 1.3. So let's do that again. 1 divided by 1.0013. I guess it needs to be overlapping the existing, right? So it's not 1.3 also. So you said 1.8. Let's try 1.5. I think this is closer to this. But this is where you ask the surveyor what scale factor they use. I think we're there. We're right on top. Yeah. Looks good.
Yep.
1.5. I don't know why they used 1.5, but it looks like it's 1.5. Yeah. It looks right on the dot. Cool. Where's the cross culvert? Right here. That's where we need the wall, right?
Can you zoom out? Yeah, so it's that one and
So this is one.
the one to the like really far
Here.
south. No, not that one.
There's something here.
I know, we're not replacing that one, cause
Oh, okay.
it's gonna be. Yeah, right here.
This, okay. All right, cool. Start with this one. First step is I want to decide where I'm gonna place like the alignment for my culvert, right? So I go to the geometry. I'm gonna create a alignment for it. So this one looks like it's skewed. So maybe something like this. Okay. And of course, I mean, you can have broken, like, you know, the culverts that have an angle between them. You can have that as well. So this one is pretty simple. This one is just straight. So we'll just do this. Gonna go to drawing production and apply an annotation. Or sorry, let's just give it a start station. So maybe do tempo 00 also. Gonna annotate this alignment. And of course I mean the scale might be 1 to 20, right? Since this is a cross culvert. Is that what or you're not sure about what scale?
Like.
For the sheets.
Yeah, I didn't get that far.
Okay, so probably 1 to 20. That's pretty typical. Usually the best thing to do is look at go by or something similar.
Yeah, I mean, can you go back and change it?
You can, yeah, well, once you cut it, kind of hard. But that's fine. 1 to 20 is pretty typical, especially for a tooling. You might even have to do 1 to 10. So I'm gonna open my profile view. I can see the existing ground, so it looks good. It looks like it's in the right place. Not sure what this is. Let's see. Yeah, I mean, something off with the existing ground here. You guys can see that, right?
Yeah.
Doesn't make sense. So that's okay. We'll be modifying these things eventually. So draw an alignment. We have the profile. Now, what am I missing? I'm missing the road components, right? So easiest way to do this is through something called a 3D cut. See this tool over here? What it does is it cuts whatever is in the way that's in 3D. So I'll show you how this is going to look. So the method is just corners, basically just draw a box. I'm just going to draw a box right here. I can see the road now, and I can see the right of way. Cool. Now I need to model the culvert based on this profile. So what I'm gonna do is I'm gonna create a component. So let's see. We're gonna change the flow here, the workflow. to drainage and utilities, the last one. Okay. I'm gonna go to layout. I'm gonna place nodes. So I need to place the head walls and then place the pipe between them. I cannot place the pipe and then the head walls. Okay. So place node. Now this is the question that it's asking me. It's telling me it will embed files for drainage and utility project in the design file. Proceed. Once you hit yes, tells you proceed, just hit yes. Now it's pulling all the libraries for drainage stuff. Let's keep hitting yes.
Just a quick question on this,
Mhm.
aerial, where is it coming from? Is it coming from a server somewhere?
Yeah, it's Microsoft Bing. See the bottom left.
And that's the only server you can get?
No, if you have a link to a server, you can add it in here also.
Okay, in case one's newer than the other one.
You can add a link like a WMS server link, but you gotta apply it as a raster. It's not through this default one. This is the default aerial. All right, so place node again. Now that dialog box doesn't show up anymore, so it's been converted to like a drainage file. Now we choose a feature definition, which is pretty much like what type of node. So a node can be a manhole, it could be an inlet, it could be a head wall, an outfall, anything really. So we're gonna look through the storm water node.
So anything that's not a pipe.
Anything not a pipe, yeah, pretty much. Stormwater node, head walls, and now depending on what type of head wall you want to use, we choose that. So is this going to be a box culvert or a pipe culvert?
And choosing. Yeah, this one's like arch pipes.
Okay.
9 inch by 3. With the straight.
I don't think TechStat has arched pipes, but we'll see. So I'm just gonna choose.
Well, like, sorry, that's what I put in HY8. The
Oh.
dry pipes.
Okay. Let's just choose a pipe culvert. Okay.
Yeah, this is where I got lost.
So many types, yeah.
Yeah, I figured out how to like do this. I didn't know you had to put in that
The
the
node.
nodes first.
Yeah.
But yeah, I got just blinded by the sheer amount.
Yeah.
I don't know what any of the acronyms mean.
Yeah, so
Third wall.
those are the flared wall. This is the degree, the skew degree. So this one, for example, let's measure the skew here on this one.
So basically, when you get over, you got rotation and you got skew. If the culvert's like this to the alignment, and the head walls like that, it's straight
Yeah,
or skewed, I'm sorry. If it's like this, you have no skew.
yeah.
I think that's a straight arrow like that.
Hmm.
Straight is like this, flared is like that.
Yeah.
But what might be helpful is to grab the actual standards and you can see them because they'll match the standard. Because you can literally see what they are, the picture.
Yeah,
Because they are a lot of them.
yeah. Here, I think we're closer to a 15 degree skew. The closest one is 15 degree. So, of course, there's the PW, which is the parallel wing, and then there's the flared wing, FW. So we're gonna go with the flared wing. The difference is one looks like a straight line, like the head walls, right? You're familiar with head walls?
Yeah.
Okay. One looks like the straight wall. The other is a straight wall with the walls on the sides that look like this.
Okay.
So
I think, can you show me the right of way again? I think that we have to do straight walls on this one.
probably straight walls because the right of way is right here.
Oh, yeah.
So I'll do this. Head walls, pipe. So parallel wing, 15 degrees Q. And then this also, like this is the pipe size. You see it, 12 inch, 18 inch, 24 inch, 72. And then the next to it is the slope. So let's try a 48 inch, 6 to 1, 15 degree. Yeah, let's try this one. Now it tells me select a reference. So like what's the elevation where you want to place this? For now, I'm just gonna do the existing ground. Oh, this needs to be 0 skew. Hold on. Okay. Vertical offset 0. And then I can rotate it based off of the orientation of the road. And I can fix this later, but this is pretty much the idea of it. Okay, so I've placed my wall. Since I've already cut this, I can just click on the refresh. Since I added that node, now I can see like I placed it under the existing ground. You can click on these also to extend the view and refresh it. So I need to do some work in terms of the elevation of this. Well, it looks just like the retaining wall.
So you just look at the natural ground.
Yeah,
And
I placed the top of it at the natural ground, which is not ideal. We'll fix that in a bit. Let's place another one. So I'm gonna use the same one. I can select, my edge of payment as a reference also. At least it'll place it closer to that elevation. And this absolute, just rotate it. Something like this. Let's refresh. Okay. Well, at least it looks a little bit better.
And we are, like, the primary purpose for this project is to expand the road at these points.
Mm-hmm.
So it'll be more like it's important that the road's a little bit bigger.
Okay. So we're gonna widen the road at that. Okay.
Yeah. Right, that's down to like one car.
Yeah.
We need it to be 2 cars. Safely.
Yeah, so right now it's 2 lanes, right? So like how much are we gonna widen this?
Your aerial, but outdated. We've realigned the road
Mm-hmm.
since then, but there's like a new bigger width.
Okay, so question, like are you widening the road the whole way or just at the culvert?
I had like a whole thing where it was like basically, well, the critical point is widening it at that culvert, but you can't like just like widen the road, right? You gotta like taper and all the taper length and everything.
Yeah,
So I think that it basically,
I mean,
yeah, so like a while.
can't fit another lane, so probably just a shoulder.
I think for
Type of
that
thing?
one, it was like, um,
That's okay. We'll widen it in a little bit. So now we got our nodes. Okay. Now we're gonna go to the place conduit tool. Go to place conduit. Change the type to stormwater. RCP class 3, for example. Oh, there is a pipe, arched pipe. Let's try that. It's slow sometimes, like it's loading, it's pulling up all the libraries. So give it a second. It's okay.
yeah, I need to work on that. I'm always,
Very, yeah.
and then everything crashes. I had an intern that was putting everything in the same file,
Mhm.
and I was like, you can't do that. And he was like, why not? And I was like, I think it's not a good idea.
Yeah.
And then it crashed on him. He was like, no.
Which one is it?
Um, 6,
6. Okay.
3 of them.
3 6s. Okay. So tells me where's the start node. Let's see here. Always go up station based on your, like my stationing is going left to right. That's because my road is going like this, right? So I'm going like this, so left to right. Because if I want to cut my sheet, I want it to be looking up station, not looking down station. Okay. And then this is the end node. There we go. I placed it. Now this is just one barrel. See? Now placed it in there. It's fitting nicely. No conflict with the subgrade. All right, now how do we make this a 3 barrel? Let's see. Gonna go to the properties. See this number of barrels, change it to 3. Now we got 3 barrels.
Does it automatically do like the text dot spacing?
It does. Now let's take a look in 3D, right? That's the most satisfying part about the whole profession. That's good, right? Now we just need to remove the retaining wall from that area. So we're gonna do some cleanup to this model since it's
I guess like, do you make a new template for like the slopes and stuff?
no, so what we're gonna do is do a point control that ties into the top of the wall in this area and this area.
So is that gonna be just put into our, I guess like, sorry, I'm trying to figure out the words. would we use the template that we already have on that stretch of road? Or would we like have a display rule, like if there's a head wall? Then,
No, we're gonna use the same template. We're not gonna touch the template. We're gonna also do the widening. You said we have to do the
Right.
How much are we gonna widen this by?
I think it's at like 18 feet and
18 each lane, you mean?
no, I think it's at 18 feet, like total.
So total is 18. So we're adding 6 feet.
I think we're trying to do. Sorry, it's been like
Yeah.
I think we're at like 15 feet. We want 20 to 20. As much as we can get.
Yeah, so
We're constrained by the right of way.
right now we have 12 and 12. Okay. I don't think we want to get closer to the right of way than this. So we might have another 8 feet on each side. So we'll get to 20 feet total. Does that work?
I had a drawing with them.
All right, so we've modeled the culvert for now. A couple of things we haven't talked about is, okay, how do I control the slopes, right? Like I want to specify a flow line for these. So you just click on this, go to the properties, the utility properties, which is the second one. Here you can specify this. See the elevation of the invert elevation. You can specify it here. So let's say I want to do 802. Did I change it? Hold on.
It looked like it changed something.
Hmm.
It looked like it changed something.
Yeah. Also, I can do it in another place. So see the culvert center line? This is not the one that I drew. There's another one next to it. It's like a line. I can open the profile for that, and it shows me the profile here. I can click on this. So right now it's locked. But if you click on the nodes, you can see here, I can drop this down, for example, to here. Or I can just type in a flow line. See that? 802. Okay, I think it's being tied to the edge of payment. So let me unlock that. Okay, let's try this here. Still doesn't work. Hold on. Set this to false. Trying to figure out.
Sorry, I got kind of pulled away on something. Is there an issue right now with the conduit?
It's not letting him update the flow. Elevation.
Yeah, and I think the reason is it's because it has an elevation reference. So it wants to keep the same height of the wall, but it's tied to the edge of pavement, so it's not letting me change that. And I'm trying to click on this. Just doesn't want to.
So is it better to like draw a microstation line and reference that instead, just so you have like the freedom to do?
Remove reference. Okay, there we go.
Oh, you can just have no reference.
Yeah.
Oh, cool.
Okay. So now we've removed the reference of the elevation. So can make this a 802, hopefully. Yeah, there we go. Cool. Now I can modify, I was able to modify it eventually. Similar thing on this right one. I just need to go to the properties of it. And same thing, set reference, remove reference. Click on remove reference and data point. Now reference is removed. I can modify this freely, so make this 804. Can even modify it to be exactly how I want it to be. Yeah, perfect. Cool. So really it's just removing the elevation reference and you should be good.
How did the elevation reference get pulled in?
Whenever we place the node,
Tied it to
it
the,
tells me select reference element. So I selected the edge of payment just to give me
okay,
something close to
there's
where I
only
want it
that
to
one
be.
that you did, the other one, the natural ground is okay.
Yeah, I can reset, you see, if I reset, it tells me reset to type and elevation. So if I know my elevation of the flow lines, I can just reset, type in, okay, let's place it at 802, for example. And then I'll just place it
So
and rotate it.
I may be getting ahead of us, but
Mhm.
we're gonna need guardrail. Right?
Yeah, that's fine. We can add that later. So I kind of have my culvert optimized. Okay, this is good for me. Now let's go back and open the corridor file so we can do the widening, the pavement widening. I'm gonna do it using parametric constraints. We're gonna add a label for the pavement width. We're gonna tell it from this station to this station, go to this width, and then from here to here this, and then from here to here this.
I don't know if we're gonna do like. I think that it was, the idea was like not to fully destroy the existing road, but to do like an overlay and then add pavement sections on it.
I see. Okay.
I mean, obviously not over the culverts, like that'll be just,
So, I mean, right now we have the template doing like kind of like a reconstruction.
we don't have to change all that.
What you want is a widening template. Have you done that before?
I think that I used it when I was trying to figure this out, where it's like just,
Yeah, just the
Yeah.
edges. We can do that. You want to do that? Let's do that. All right.
We talk about extending the culverts instead, what we're talking about.
They want to keep the existing road, but just widen
Why-
instead of like a reconstruction. So we're gonna change the whole template. But we're gonna come to template. And if we think about this, right, this is like changing something so drastically usually wouldn't happen. Like you don't go from a reconstruction to a widening. But since we already have our template tied in to the right of way and everything, I don't want to mess with that. So here's my template. First, I'm gonna create a copy of this. Paste. I'm gonna call this widen without ditch. Sure. All right. Let me think. Maybe it's good to just start from scratch because it's going to be more work to modify this one. So, yeah, let me just delete everything. Okay. This is scratch, start from scratch template.
I love that tool, by the way. I didn't know about that.
Okay. Delete.
Yeah.
Yeah.
Wasn't there an option widening already a template for that text out?
For widening?
Yeah.
I'm not sure, honestly. I
I
haven't.
think so, saw one. Or maybe it was. I don't know where I got it, but I definitely. Maybe I know it.
Yeah. Oh, yeah, I think there is a widening one. I remember. Yeah. I just remember it.
Yeah.
This one. Yeah. Should we use this one, I guess? Okay. So I'm just gonna create a copy of it. Just dragging it, putting it into the new one that I created, the widen without ditch. And if you notice, if I place it anywhere other than at the 0, 0, that's like usually the template follows the profile at the 0, 0. So if I have it at an offset, this offset is going to be throughout the whole corridor. Like it's not going to be at the right profile elevation. It's going to have the horizontal and the vertical offset. So you don't want that. You got to be careful. So here I would have about a 0.6 foot offset from my actual profile. The cross sections will all be wrong if you have this. So what you do is right click and change template origin. See this one? Change template origin. Takes it back to the 0, 0. That's it. All right. Okay, I'm gonna delete components, delete all these. Keep this berm, that's okay. And delete these. This is 12 feet, that's close to the existing. And then we're gonna widen, we said 8 feet. Same thing on the left, -8. I can do this, or I mean, you know how to recreate this from 0? If I wanted to recreate this template, do you know how to do that?
Scratch or like copy it?
From scratch.
Yeah, I fiddled around with it and.
Yeah. So are we gonna overlay the existing road actually or no?
Yeah.
We are? Okay. Because it depends if we're gonna overlay it or not. Like are we gonna actually have this
I think
section in the
that
middle?
was the goal. Yeah, because our we had like the realignment of the road for our road project, and I was using that as the go by. And they had some sections that were mill and overlay for the existing road and some that were new.
Okay.
So I think we'd go with the mill and overlay.
Okay, I'll keep this one and then I'll show you another example if we were to keep the existing and then just add the widening. Because this one is following the center line.
So would you just take, you would just reference like the widening part to the center line, but make the center line like
Ye-
have no
Yeah,
blocks connected to it.
that's the tricky part is sometimes between the center line and the edge of pavement, the existing edge of pavement, it's not 2%. Could be 3%, could be 4% sometimes, depending how deteriorated the pavement is. So the question becomes, are we gonna keep that as 4% and just the widening also becomes 4%? Or are we gonna do 2% at the widening? Or are we gonna overlay the whole thing and just make it all 2%? You know, that's a decision of
Design
that.
point, that's easier, but it's more.
Yeah, yeah. So
The
really,
question is if they want to add 20-year life to it, then they gotta add 4 inches or something to it, so they're gonna.
to level it. Yeah,
I don't know the project, but more what I'm finding out is they want to give it a 20-year pavement life,
yeah.
but
Yeah, end of the day, it's really up to the project manager or I mean, whoever the decision maker on this is. So right now, this is just doing an overlay and tying it to the center line, and we're saying we're gonna level everything to 2%. Just keep it at that. No matter what's happening with the existing, we're just gonna do 2%. The only thing is we want to maintain the existing center line. So
And are those, you're like, where it begins, the widening?
Mhm.
Are those dependent on the existing edge of pavement?
Yeah,
And then could we do like, you know, whatever, -6 inches or something?
yeah.
It's pretty dilapidated in some areas.
So right now it's 12, so we can make this 11, for example. You know, just do a saw cut a foot inside the
But like,
existing pavement.
the existing pavement goes like this, so is it, when I say based on, is it reading the existing pavement and doing 11 from the center?
We just like we found the existing center line, right?
Right,
So then we're going 11 feet and saying this is where the saw cut line is.
okay.
So we're just gonna cut the pavement there and then just add the widening next to it.
if there's more or less, more pavement on it, then it's gonna get cut out.
Yeah. Yeah, if it's like 13 feet from the center line to the edge of the existing, we're gonna be having to cut 2 feet.
Okay.
So just gonna keep it standard like this. All right, we have the widening, we said 8, so this 8 now becomes 9, right? Because we took out a foot.
Oh, I'm sorry. I know we keep going, then I keep asking questions.
No, no, you're good.
In our pavement section, we're gonna do like prime coat and
Yeah.
tack or whatever.
Mhm.
Do you recommend just putting, because I know that it's in there,
Mhm.
but like, do you recommend just like putting the line in there and then using that for your quantities? Like, I guess,
Uh,
how do you do that typically?
Personally, I don't model it. I mean, it's just a layer, too small of a layer.
You just measure the surface area.
Just measure the surface area and put it
But
in
like,
the
you know,
quantity.
when you get your quantities sheet, like you could have it, like an item for that.
You can
So
if you add a line.
If you put
Yeah.
like a line in there, would it still calculate?
Yeah, I will. Well, you just need to specify the right feature definition for that line. But I mean, it's pretty simple, just getting the surface area from plan view. All right, so we got these. Let me just fix this one. It added R since we like copied it over. It just adds these underscore L and then underscore R to everything. All right, so what I'm gonna do also is use this one that we've created before. Before I do that, see that apply affixes. I don't want to apply affixes. Just drag it. Now it kept these same names that I gave it before. I'm gonna delete these. Gonna move this, put it here. Arch points. I'm just gonna delete this display rule. Move it. Put it here. Arch points. Do this. Let's do 10%. Okay, 10%. Do this minus 10, 10%. Okay. Got everything here. Right. Should be good to go. I'll just save. Close. Hopefully when I swap this out, it should be pretty straightforward. All right. Take a look at the sections now. This is what I was telling you. You see, like the existing is different. Could be 3-4% here. That's how my section is looking like. Close to my culvert. Seems like we need to use a higher head wall or raise the flow line a bit. Seems too low here. But on the skew, it looked okay. Like when you look at it perpendicular, it looks off, but at the skew, it looks fine.
That's true.
I think they ended up leaving us with like 1 foot of cover.
Mm. Cover where you mean on top of the
Yeah.
yeah. Yeah, plenty. It's not 2 feet right now. But on this side it's different. Oh, we'll come back to it and adjust it. Okay. So it's looking good, right?
Or over 1 foot of cover, because I think 1 foot was like the minimum.
Yeah. So far it's looking okay. You can see it's still tying into the right of way. Because you know how I reuse the same point names? And I reuse those like segments for the ties. I maintained my point controls, still working. Even though I swapped everything in the middle. So that's all.
So question on the culverts, when you were going through the sections, you saw 3 circles.
Yeah.
We have 3 culverts?
Yeah.
We have 3 culverts.
Yeah, triple barrel.
Okay. It was odd to see that it was like looking at them, not laterally, not as a section, but as a. has
Cross-section.
elevation view kind of, well, that's not what I'm trying to say.
Cross-section, you mean?
Yeah.
Yeah, depends how, you see that blue line?
Uh,
Depends how, you
you
see this?
right.
It's cutting through the three of them at a skew. It's not cutting along the culverts.
Oh, I see it, kind of hit it 3 times
Yeah,
at 3 different points, I guess.
yeah. All right, so we've widened this, but did you mention it's only the widening is only at the culvert or?
The critical part for the road widening is at the culvert, and
At
I
the
think
culvert.
past that, it's just tapered.
We go back to the 2-lane. Okay. That's what I wanna do now. So let's come back to this. Trying to think how we're gonna do this. Okay. I think I have an idea. We're gonna have to use a different template, like at the culvert area. So I'm gonna copy this, paste it. I call this exist. Now the existing one will just be no widening, just overlay, correct? And I'm gonna delete those points.
Recording, right?
Yeah. I'm just gonna keep that top layer.
Wait, I'm confused. But isn't the taper also gonna be not? It just,
What taper?
like, cause we did it at the cross culvert, and then won't it do the same?
No, outside, imagine outside the culvert area.
Right.
How's the section gonna look like? Just a million overlay, right?
Well, it can't be, because it's, what she's saying, is they're building the full width pavement at culvert, and then they're gonna taper it back down
Yeah,
to existing, so at some point, it's gonna go from 8 foot, 7 foot, 6 foot, 5 foot.
yeah. No, I understand, yeah. We're gonna go back to that because that's a different template. Now I'm looking at purely outside the culvert area. Like forget the tapers at the culvert as well.
Just the overlay.
Just the overlay, no. This is just an overlay template. That's it. So I have edge of payment right, edge of payment left, everything is still the same. Okay. It's just an overlay. Pure overlay. Just gonna do it one step at a time. Usually I would want to draw the geometry, the taper geometry and all that. In
Oh,
plan
no,
view.
I just cannot.
Yeah, that's okay. So, I guess we'll create a geometry file in a second. Let me just swap the templates. So this will be just an exist without ditch. Okay. It's gonna look like this. Simple. Oh, we forgot to change the width.
What happens if profile happens to be below the natural ground? an overlay? Will it still draw 50% of constant depth?
If the profile, sorry, can you say that again?
So is everything constant thickness, even if the profile, if the profile, proposed profile is lower than existing ground at a particular section?
Yes.
Or theoretically, it's not a really an overlay.
Yeah. So we need to get the existing profile, centerline profile as close as possible, right? We didn't really do that here. Like we just did something close, but it's not exact. So we would want to be more precise and get the actual existing profile. That way there's nothing below the existing. It's just at the existing or it's at the existing. Looks like the existing is even less than 11, less than 12. Yeah, so here there's going to be a taper, correct, from this point up to the culvert, and then it's going to stay constant through the culvert, and then taper back again after here. So I'm going to split this as well. Approximately, say, from here to here. I'm going to use the overlay one in this area as well. Okay, so we got the 12-foot lanes, the widening one, and then 12-foot, and now we just need to fix the tapers. So we can either do a point control, or we draw the geometry and just do a point control for it to follow, or we can just do a parametric constraint, which I'm going to do over here. I come here and double click on this. There is a label called pavement width right for the horizontal. You see that? So that's good. Left side, same thing, pavement width, left. So we're good to go for setting up the parametric constraint. So I'm going to come here, create a parametric constraint, click on the corridor. I'm going to start right here. I mean, this is not really calculated tapers. This is just you can do. Yeah, time for detail later. I'm gonna stop it right here. We're gonna flip through to get the pavement width right. Okay. I'm gonna tell it start at 0. Okay. Stop at 9, which is what it is right now. So just like that, we got our taper. Okay. And then the other side. Start here, here. This is gonna be also a pavement width right. Start at 9 and end at 0. It's gonna be the opposite. It'll look like this. We'll figure out why there's a small difference here. Oh, I know why. Because we did 12-foot lanes here and we did 11 here. So I'll have to come back and fix that. All right, do this and then do the same thing on the other side as well. So starting here and ending here. Gonna do pavement width left. Start at 0. Okay, and stop at -9. Then the last one. -9 to 0. Cool.
Yep.
Let me just modify this. I think the existing is closer to 11 rather than 12, honestly. That's what I saw from the existing section, so I'm just going to make these 11. All right. Perfect transitions. Extend this a little bit here. And there we go. For 3D. I'll say it's the best way to QC your work. Change this to this thing. So we were to look from the bottom. I mean, there's still some cleanup that we need to do at the culvert, but just looking at this now. See this? Shows the full depth widening.
I'm trying to put this together in my head. So the parametric that we did,
Yeah.
we didn't need the widening template. You in fact we destroyed it. You just used the overlay and told it what you wanted it to do. Hard coded a number in to go out to.
Not exactly. So what we did,
And then the other one was had a actual widening structure.
yeah, so I split my work into two templates. One that has a widening and one that's just an overlay. I applied the overlay template from here to here. And then I applied the widening one from here to here.
Okay.
And then from here and on, it's also the overlay one.
Yes.
In this area right here, where we have the widening, right?
Yeah.
It's a constant width in the template. What I did with the parametric constraint is I told the template, change the width of this from this station to this station from 0 to 9 feet. And then the opposite on this side.
So there's already a template right there. There was already a template.
It's already a template, yeah.
And then you overrid it kind of.
With the parametric constraint, yeah. Yeah.
The overlay, and then we had the full widening or the widening.
Mm-hmm.
And then you made it even smarter by showing the tapers.
Yeah.
So really the only part that has widening, true full width widening as it was originally put down is on top of the culvert.
Yes, exactly, exactly.
Only that small piece.
Exactly. Cool.
Cool.
So really there's only two templates. Two template drops.
Two template drop. 3 template drops. One before, one through, and one after. But 2 templates.
Okay, two templates.
Yeah, template drops is just the sections.
Okay. Let's get the templates, and then just actually, I'm using 2 templates, but I have drops, and drops is where they're independent, depending.
Yeah, exactly.
So they're unique.
Yeah.
That's just intense. So yeah, I was getting confused when I was looking at these cross sections because when I looked at it here, I thought I would see a line across, but instead I started perfectly looking back at me as if I was looking this way.
Yeah. Yeah. Cool stuff. It just cuts whatever it sees. You know. This is the future.
This is the now.
Yeah. Now we want to add the guardrail, right? So let me show you how to do that. Come back here. Thankfully, Guardrail has its own feature definition. So if I go to geometry and lines, I select a linear, where is it?
Yeah.
Guardrail and barrier. So what kind of guardrail do you want to have? The SS, not the SSDR.
I didn't get that far.
I guess
Wait.
not the cable, probably. Probably a regular guardrail, right? Let's just use this one. Metal beam guard fence.
Yeah.
And are we gonna, I mean, there's two options, either put it on top of the culvert, the head wall, on top of the head wall, or we can do it like next to the road.
On top.
Yeah.
I mean, unless I have never seen one constructed on top, but I feel like in the interest of space, right?
Yeah. Okay. Oh, sorry. Right. Okay. I'll need to move it, but let's just put it on top for now. Now you see the posts, they're over here, so I'll just need to move it up a little here to have the posts on top of the head wall, so they're embedded in the head wall. Something like this. This is just a line style, by the way, up till now. Okay, so I'll need to define a profile for it. How do I get the profile of that area? Easiest way is I go to profile creation, quick profile from surface, click on the element, click on the surface. I'm just going to take this as a surface and reset. That's it. Select this, make it active. Now, if I go back here,
Where's the origin for the line style? Because it's horizontally, vertically, I think. Kind of like the cell had, the wall had to go at the top of the head wall. For the line style, was there an origin in the profile?
there is, to be honest with you, I don't remember exactly where, so we'll have to see here how it drew it. We'll kind of tell. Right, and here's
Looks right.
correct, right?
So the origin is on the bottom there,
Yeah,
or before the embedment dip.
it's probably really close, anyways, because they're right next to each other. Whether it's the top of pavement or the top of head wall, they're probably going to be very close.
You put it in like not one.
Yeah, transparent. Let's just do smooth. Yeah, this one looks good. There we go.
They've got the low strip on there.
They got the screws even.
Impressive.
Yeah. I mean, I can have the tapers also on the terminals. Right, I think the terminals are there also. We can add the terminals.
Like the grass.
The crash cushion or
Oh, right.
yeah. It's looking good. All right. This is as far as the guardrail. What's next?
If you're going to get fancier, it's supposedly, wherever you got guardrails, so like at the approach, you should have a 10-to-1 flatter, might actually be 6-to-1 flatter.
Yeah.
That special little area, but you're gonna model that, because that's what can get you into trouble at the right of way line.
Yeah. True. Yeah. I mean,
But for this purpose, I mean, I think we know that it can be done.
yeah. Yeah. At this point, it's really just detailing this area out. So we can add point controls to tie to the top of wall. We can push the guardrail a little bit back. We can widen the berm. Remember the berm? We can widen it a little bit, also using perimeter constraints in the area to show a minimum. I think it's 2 feet or 18 inches.
Okay, so this is all in the line style. This is only the feature definition on the line that we, smart line that we drew
Yeah.
in a profile, and we didn't use a template for anything.
No, nothing. Which is a nice thing about Guardrail. It's because if we do a template, if you remember, templates are an extrusion of a polygon.
So it's, it's a volume.
Yeah, I wouldn't get those spaces. Like I might
That makes sense.
get just like a block, you know. Of course, I can also always model the cross culvert in a template. The very first time I did a cross culvert, I did it in a template. We didn't have any of those libraries, like all the pipe libraries, like they weren't there. I just did an alignment and I created a square in the template and I ran along the alignment, and that's pretty much all you need, right? So. All right, so we're done with the modeling part. Let's go to the production part.
If we can take it.
Oh, yeah, sure. Let me
You
stop
go to
the
the break.
recording.
Sure, yeah.
Let's get sore.
Yeah.